Hello, in the last videos we discussed what is binary search, what are lower and upper bounds, and how to find those in map, set, vector of pair, and so on. And now let's discuss a problem. Given a vector of size n and four variables a, b, x, and y, we have to find number of pairs that satisfies the condition sum of a into vi plus b into vj lies in the range x and y. So x less than or equal to sum and sum less than or equal to y. And we have to find the different pairs. That means a same index cannot be considered twice. So for example, if a is equal to b is equal to 1 and x equal to 2 and y is equal to 4 and the given array is this, first 5 values are 1 and the last value is 5. So to find the number of pairs which satisfy the given condition, 1 plus 1 is lies in the range and 1 plus 5 does not lie in the range. So all the pairs which are 1 will be considered. So the answer will be 10. Let's assume that we are taking I index I and j and I is less than j. So starting with index 0, we can pair all the numbers with 0 from 1 to 4 because we cannot consider 0 because we cannot use I equal to j, and the sum of index j, index 5, 1 plus 5 does not lie in the range 2 to 4, so we cannot consider fifth index and 0 index as well. So for 0th index there are 4 possible pairs, and for 1 there are 3, and for 2 there are 2 and 1. So finally the answer is 10 because 10 pairs satisfy the given condition and the size is less than or equal to 25. So how to do this? So we want to find this. Let's assume that we are trying to find as a problem where the sum is greater than or equal to x. Here the sum is from x less than greater than or equal to x and less than or equal to y. So for now let's assume that we have to find the sum greater than or equal to x. So how to do this? Let's say we are traversing the array and we are at index i, and now we are trying to think what are the possible indices of j such that the given condition satisfies for this index i. So this condition refers this because we are thinking about subproblem now. So we are at index A and we are trying to find the values of indices j for which this condition will satisfy. So by rearranging this, we can get that b into v of j greater than or equal to x minus a into v of I. X is given, a is given, and v of I is the present value, and v is also given. So we can find the range of v of j for which this will satisfy. So for example, after calculation, if the possible case is 4 into v of j is greater than or equal to 13. This is the first case, and 5 into v of j greater than or equal to 15. Let's take this as second case. Why there are two cases? Because, for example, in this case, this value is divisible by this. So directly we can say that we are checking for the values where v of j should be greater than or equal to 3. But here, if the case is 4 into v of j greater than or equal to 13, the value will not be v of j greater than or equal to 3 because 4 into 3 is not greater than or equal to 13. It is less than 13. So if the value is not divisible by b, then we have to add 1, and then for all greater than or equal to that values will satisfy. So if x minus a into v of I is divisible by b, the value we are searching is just the division, else we are incrementing by 1. So if it is divisible by 0, we are searching for value divided by b, and else value plus plus because it is 4 here. But how to find this? We are at index I and we want all the values which are greater than or equal to some certain value where we have found value from these above based on the divisibility rules. So what is lower bound? So it returns the lowest index which satisfies the value which is greater than or equal to some value. So we want the exact case here. So we can use lower bound here to find the smallest index which satisfies the given condition. So to use this way, we have to first sort the array. So that if you are, for example, we are at 0th index, we can find what is the least index that is satisfying this, and based on this, we can return the answer. So for example, the array is 1 1, all are ones, and we are at index 1. So now based on the this example, we found that answer should be v of j greater than or equal to 1 to satisfy the condition. So if the condition is this, then lower bound will return 0th index because this is the first index where the value is greater than or equal to 1, right? So it will return the 0th index. But as we have discussed before, we are checking for indices I and j, where if we are in index I, we are trying to find the pairs which the condition will be satisfied for greater index, because a pair can be counted only once. And from this example, we saw that we are taking index I and we are pairing the numbers with the integers in the right index with the greater index and that. So we are at index I and we want greater index, but here we are at index 1 and lower bound returns 0. So how to take care of this? Because we thought one and lower bound is written something. So we can try to take, if the lower bound returns index j, which is 0 here, we can do j is equal to maximum of j and I plus 1. Because if j is less than I plus 1, if j is greater than or equal to I plus 1, we are okay, because surely the index j is in the right side of index I. So this is already satisfied. And if it is less than I plus 1, we are doing maximum. So now it will become I plus 1. So based on j and I plus 1, this will surely point to an index which is greater than I, where we have discussed the initial case. So we found that index I, the lower bound is returning j, and we also discussed that for index I, we are trying to pair the present number with an index which is greater than the right side. So we are trying to maximize this so that j will always be in the right side of the index I. And for example, if the present index is this, and after maximizing 0, 2, the lower bound is indirectly returning this, because we are doing maximum. And now all the numbers after also will be satisfied, because the sum of numbers at index 1 and index 2 is greater than or equal to some given value. So all the numbers are greater than v of 2 in the right side, greater than or equal to v of 2. So obviously their sum will be still greater than or equal to given number. So our main condition is sum is greater than or equal to x. So if we find the least index that is satisfying, every index which is after it also will satisfy the given condition. For now, we solve the first part, greater than or equal to x. But how to solve the second part, which is less than or equal to y? So for a into vi plus b into vj greater than or equal to x, what are the possible values of these? It should be greater than or equal to x. So x, x plus 1, x plus 2, and so on. Y minus 1, y plus 1, and so on. And similarly, if we try to take the values greater than or equal to y plus 1, y plus 1, y plus 2, and so on, will satisfy the given condition. But we want only the values till x and y, right? Because we want the values between x and y. So if we are taking only greater than or equal to x, these are remaining. These are extra, y plus 1, y plus 2, and so on. So we want to remove this in anyhow. So what if we try to take the answer for greater than or equal to y plus 1? So if we find the approach similarly for exactly one like before, with the value y plus 1, we will get all these values. So if we directly subtract all this, we will get the given condition where the sum is between x and y. So we found an approach for answer to find when the sum is greater than or equal to x. And similarly, if we found the answer for y plus 1 greater than or equal to y plus 1, and difference of this will give the answer for x and y range inclusive. So by subtracting, we can directly get the answer. So let's check the code. We are taking the input a, b, x, and y, and n, and we are taking a vector. We are sorting it to get the lower bound. And now we are finding the first part, where first part is we are finding the number of pairs where sum is greater than or equal to x. So as discussed in the before, we are traversing the array and we are finding the value where we want from the upper bound. And if it is divisible, we are not going to change anything. And if it is not, we are incrementing the value. And j is equal to lower bound of v dot begin and value minus v dot begin. This will return the least index that satisfies the given condition. And j is equal to max of j I comma I plus 1, because we are trying to pair the present index with the greater index. And now answer plus is equal to all the index from j. So n minus 1 minus j plus 1, because the index of last element is n minus 1 and the least index that is satisfying is j. So all numbers from j to n minus 1 will satisfy the answer. So n minus 1 minus j plus 1, and finally returning the answer. Similarly, we are trying to find the answer for greater than or equal to y plus 1. So second part of y plus 1, similarly the exact code. So it will return the number of the answer for greater than or equal to y plus 1. So just by subtracting it, we can get the answer, which is 10 in the given example. So now we discussed that we can do with the lower bound. Now let's try to implement this without using the STL function, and let's try to implement this. So how to implement this? For example, we are trying to find the least index which is greater than or equal to 5 in the given array. So the value is 5 here. So we are trying to find the least index with the value greater than or equal to 5. And now we are searching in the whole array. So as we are searching the whole array, low is the 0th index and high is the last index, because these are the least and the highest index possible which are answers. So low is equal to 0 and high is equal to n minus 1. And now let's assume that the mid is the the mid we are at is this, and that value is 3. So is mid value greater than or equal to 5? No, this is less than 5. So we are sure that answers will always be in the right part, because as the array is sorted and this element is not greater than or equal to 5, then we are sure that any of the previous elements will not be greater than or equal to 5, because it is sorted in the increasing order. So this is not greater than or equal to 5. So obviously, if the answer exists, it will exist only in the right part. So the new search space is mid plus 1, because even mid is not satisfying. So it is no need to consider mid as well. So now the low will be mid plus 1, which is this plus 1, and the high, which is before high. So we are just incrementing low is equal to mid plus 1, because the mid value is not like greater than or equal to 5. So obviously any values before this are also do not satisfy the condition, and the new low will be mid plus 1. And similarly, and now if we are at mid, which is this, the second case, and we are at 5. So now the condition is satisfied, which is greater than or equal to 5. So we found an answer, because we found an answer with the index greater than or equal to 5. So after finding this, can we break the loop? No. From this example, we can see that we found the answer, and we can just try to make answers equal to mid, and we can break. But is this true? No. Because let's take other example. For example, if the values are 5, 5, 6, and the mid we are pointing to is 5, the value is 5. So now even similarly, we found an answer which can be an answer. We found a mid value which can be answer. But there can be greater than or equal to values before it as well, because we are not sure that all elements are unique. So the values in the given array can be duplicate as well. So if the present index is 5 and we are at this, there can be many before elements which are 5 as well. So we found an answer, but it is just a possibility of answer. So we can store answer is equal to mid, and we can decrement the high range, because we found a least index. No need to check in the highest, because even if we find some 5 here, we found a lower index which is present on. So we are sure that no need to check in the higher one. Maybe 5 can exist, but we found an index with the given condition, and now we want the least index such that it satisfies the condition. So we are trying to decrement high, because we are going to search in the left half. So high is equal to mid minus 1. So if the value is less than mid, we are going in the right search space, and if it is equal, we are making a possibility of answer, and we are decrementing the mid, we are decrementing the high. So let's check the code. Here, instead of lower bound direct function, I have just taken another function and written its value. And now low is equal to 0, high is equal to n minus 1, and mid an answer. Initially, let's assume that answer is equal to n, because there may be a case where there is no answer. For example, the highest value in the array is 10, and lower bound is asking to return for the 100. So there is no value. So mid is equal to low plus high by 2. And if v of mid is greater than or equal to 12, so we can store in the answer, and we can decrement high, because we are going to search in the left half. And similarly, if it is not, you are incrementing low, because we are searching the right half. So finally we are writing the answer. So this is just the lower bound HTML implementation. Hope you understand this. If you have any doubts, comment below, drop a like. See you in the next video.